Namaste. Good afternoon. Today's lesson, continuation to yesterday's lesson. We have seen perpendicular, foot of the perpendicular image of a point on a line in the previous class. Today, a continuation to it is the perpendicular distance formula we are going to derive. And after that, distance between the parallel lines. Today's lesson, continuation to yesterday's lesson. Distance between the parallel lines, and thereby we will be understanding how to find out the area of the parallelogram. Because in a parallelogram, the opposite lines are parallel to each other. Two such sets of lines forms a parallelogram. So, and after that, we will have the angular bisectors. Angular bisectors of two lines. If two lines are there that are non-parallel, what does it mean? If they are non-parallel, they are intersecting. Obviously, when they are intersecting each other, there will be one angle formed in between them. If this angle is acute angle, obviously this angle becomes obtuse angle. So if this angle is, for example, 60 degrees, then another line divides it into 30-30. Another line divides it into 30-30. Then that line is said to be angular bisector. If this is 60, this will be 180 minus 60, 120. If a line is dividing it into 60-60, that is said to be also angular bisector. But what is the difference between these two? This is acute angle bisector. This is acute angle bisector. And this is obtuse angle bisector. That's what the difference. You have to understand that. So, we will be finding the formula to find out the angular bisectors of two given lines, and thereby, after that, we will be understanding how we decide a particular angular bisector is an acute angle bisector or obtuse angle bisector. This is what the next part of the perpendicular distance. Okay, so to begin with, we have the perpendicular distance formula. Harshini, good afternoon. Arun, good afternoon. So, perpendicular distance formula is very simple formula and important formula. Important formula. Why? Everywhere throughout the coordinate geometry, you will get this one. Perpendicular distance from a point to a line. Perpendicular distance from a point to a line is always to be used. See, whenever the distance from a point to a line is simply, it is given like that. Distance from a point to a line, simply if it is given like that, understand that it is nothing but the perpendicular distance. Because the shortest distance is always a perpendicular distance. For example, I am standing here. This is the point. Now, if I want the distance from this point or from me to that wall, this distance is always measured perpendicular. This distance is always measured perpendicular. But distance means we don't calculate cross. We don't calculate inclined. It is always to be calculated perpendicular. Simply the distance between a point and a line is nothing but the perpendicular distance. So we are going to derive the formula for the perpendicular distance. So perpendicular distance the data from a point x1, y1 to a line ax plus by plus c equal to 0 is modulus of a x1 plus b y1 plus c divided by root over a square plus b square. Units please, because it is the distance. This is a statement. Perpendicular distance from a point x1, y1 to a line ax plus by plus c equal to 0 is modulus of ax1 plus by1 plus c by root over a square plus b square. Okay, the proof goes like this. Simple proof. We will have the concept of, in this proof, we will be making use of two concepts. Number one, shifting of origin. Number one, shifting of origin. Number two, the normal form of the straight line. Number two, the normal form of the straight line. How do we do that? Just see this. Just see this. This is y-axis and this is x-axis. This is a point here. P x1 y1 and this is a line. Given line please. Ax plus by plus c equal to 0. Now I need this distance here. I need that distance there. Okay, how to find the distance? See how you have to think while deriving this. It's a smart thinking. Like, if you remember the normal form. What is the normal form? X cos alpha plus y sin alpha is equal to P. I hope you all remember that. X cos alpha plus y sin alpha is equal to P. What is P there? It is a perpendicular distance from the origin to the line. It is a perpendicular distance from the origin to the line. So, if any line is given, we can convert that line to the normal form by dividing with root over a square plus b square. I discussed this in my previous videos. I discussed this already. So what is that? Ax plus by plus c equal to 0 is a line. Then to convert it to the normal form, you have to divide with root over a square plus b square. After dividing it with root over a square plus b square, we shift the constant to RHS. Thereby, we will be understanding that RHS part is nothing but the perpendicular distance from the origin. So, in that form, we know the perpendicular distance from the origin, but in this form, we don't know the perpendicular distance from x1, y1. This is what the difference you have to observe. So, what is that we do? This is smart thinking. What is that we do? We simply shift the origin to x1, y1. Thereby, what happens? This x1, y1 will be the new origin. So, what is the first step to be done? Shift the origin. Shift the origin to x1, y1. x1, y1. Okay, shift the origin to x1, y1. Therefore, what is the relation? I discussed this in introductory videos. In the beginning, I discussed the shifting of origin in the introduction part of coordinate geometry. You must be remembering that original point is equal to new point plus new origin. Original point is equal to new point plus new origin. Original point is nothing but small x, comma small y is equal to new point plus new origin. I derived this also, please. I derived this in my previous videos. Okay, so what is it happening when you are shifting the origin? When you are shifting the origin to some other point x1, y1, obviously every point on the plane will be changing. When every point changes, the line is made up of points only. And hence the equation of the line will also change. That is called transformed equation. So, transformed equation of line is transformed equation of line is what happens in place of x small x you have to write x plus x1, in place of y you have to write y plus y1. So a of x plus x1 plus b of y plus y1 plus c is equal to 0. This is the called transformed equation. Thereby, ax plus by is equal to minus of ax1 plus by1 plus c. Why I shifted that constant to RHS? Now I want to convert it to the normal form. If I convert it to the normal form, then the RHS is nothing but the distance from the origin. What is the origin here? X1, Y1. Because we shifted the origin. So this implies AX. What is that? You have to divide with root over a square plus b square. That's what I'm doing. A by root over a square plus b square into x plus b by root over a square plus b square into y is equal to minus of ax1 plus by1 plus c divided by root over a square plus b square is in the form of x cos alpha plus y sin alpha is equal to b. Let me write that. X cos alpha plus y sin alpha is equal to p. What is there in place of p? It is nothing but minus of ax1 plus by1 plus c by root over a square plus b square. We don't take that minus into consideration because it is the distance. The distance should always be positive, and hence we write the modulus to the term which is present in the RHS. Just to see what is a term, it is there in RHS. It's nothing but minus of ax1 plus by1 plus c by root over a square plus b square. That is nothing but the perpendicular distance formula. Okay, so finally the perpendicular distance from a point x1 y1 to a line. Therefore, perpendicular distance from x1 y1 to ax plus by plus c equal to 0 is modulus of ax1 plus by1 plus c by root over a square plus b square units. So that's what the derivation of perpendicular distance. Now, frequently used one is the perpendicular distance from the origin to a line. From the origin to a line. Obviously, when it is from the origin to a line, this x1 y1 becomes 0 0 0 0. Substitute 0 0. What is the remaining c? So it is simply mod z by root over a square plus b square. So what is our learning here? Number one, the perpendicular distance from x1 y1 to the line ax plus by plus c equal to 0 is modulus of ax1 plus by1 plus c by root over a square plus b square. Number two, the perpendicular distance from the origin to a line is nothing but mod z by root over a square plus b square. This is about the perpendicular distance formula. Okay, now distance between the parallel lines. Distance between the parallel lines. You have to remember this. It must be on your tongue because the frequently used formula even further in circles, parabola, ellipse and hyperbola also you will be getting this perpendicular distance frequently. You will be getting this perpendicular distance frequently. So you have to remember that. Okay. Now let me derive the formula to the distance between the parallel lines. Distance between the parallel lines. distance between the parallel lines I'm not just teaching you the objectives, but I'm deriving it just to make the concepts more clear to you. Just to make the concepts more clear to you. Okay. So what is that now? I'm deriving distance between the parallel lines. This is one line. This is another line. This line, x plus by plus c2 equal to 0. This line, x plus by plus c1 equal to 0. Very important point to be observed. Very important point to be observed. The slopes of these two lines are equal. That means the coefficients of x and y must be equal. Even when you are applying the formula, there is generally a twist in the question. Like what, you'll be given something like 2x plus 3y plus 1 equal to 0. 2x plus 3y plus 1 equal to 0. And you will be given 4x plus 6y plus 2 equal to 0. Here 4, here 6, here 2, here 3. They are proportional. There's no doubt. But while applying the formula, you make sure that both the coefficients will be same. That means you have to multiply this with 2 and you have to make the coefficients the same. Then only you can apply the parallel lines distance formula. Okay, we'll be seeing that. Now, because now we know the distance between the perpendicular distance from a point to a line, we choose a point here. Let us choose a point here. Let it be some px1, y1. Okay. Now, P belongs to this line. P belongs to ax plus by plus c2 equal to 0 implies if you substitute it ax1 plus by1 plus c2 equal to 0. Why should it be? Because the point is lying on the line. The point is lying on the line. Now, I'll do like this. Now I am finding the perpendicular distance from P to this line. Just now we derived it. What is the perpendicular distance here now? What is the formula we have derived? Modulus of ax1 plus by1 plus c divided by root over a square plus b square. The same formula we are going to apply now. So, if you apply that formula, here, perpendicular distance from P to 1. This one. This is, I am saying it as 2. This as 1. This is the perpendicular distance. Is equal to modulus of ax1 plus by1 plus c1 divided by root over a square plus b square. This is the distance from P to this line. But let it be 3. Let it be 3. Now what is ax1 plus by1 here? Minus c2. Substitute here. Modulus of minus c2 plus c1 by root over a square plus b square. Therefore, distance between, conclusion, the lines ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 is modulus of c1 minus c2 by root over a square plus b square units. Understand that, please? C1 minus C2 by root over A square plus B square. So generally, what is that point you have to remember, even in the previous questions also, the questions were given like this only, what I'm going to tell you now. A question is given like this. Distance between are you with me? Distance between 3x plus 2y plus 4 equal to 0 and 6x plus 4y plus 1 equal to 0 is, just observe the question. Just observe the question, please. First line is 3x plus 2y plus 4 equal to 0. Second line is 6x plus 4y plus 1 equal to 0. 6x plus 4y plus 1 equal to 0. Okay, what is the difference? What is the difference, please? First line coefficients and second line coefficients are proportional but not equal. Are proportional but not equal. I'll write this below this line. 6x plus 4y plus 1 equals. Check it out, please. 3 by 6 is equal to 2 by 4. 1 by 2, it is 1 by 2. There's no doubt. There is no doubt they are parallel. There's no doubt they are parallel, but they are not suitable for us to apply the formula directly. It is not suitable for us to apply the formula directly because the lines are ax plus by plus c2 equal to 0, ax plus by plus c1 equal to 0. They must have the same coefficients, and hence in this question now, what is to be done? You have to multiply this with 2, please. You have to multiply this with 2, then what happens? 6x plus 4y plus 8 equals 0. Now apply the formula. If you apply the formula, what is that you get? C1 minus C2, that is modulus of 1 minus 8 or 8 minus 1, whatever, divided by root over 6 square plus 4 square. Is nothing but 7 divided by 36 plus 16 root 52 units. So whenever the coefficients are not equal, even though proportional. Whenever the coefficients are not equal, even though proportional, then you have to make the coefficients equal like this. What is that I did? In this case, it is 3x plus 2y. In this case, it is 6x plus 4y. So I multiplied the first one with 2 and thereby it becomes 6x plus 4y plus 8 equals 0. Now these two are equal. Now apply the formula c1 minus c2 by root over a square plus b square. Okay, this is about the parallel lines distance. Final formula, modulus of c2 minus c1 by root over a square plus b square. Okay, now next is the angular bisectors. Angular bisectors we will be coming after discussing the objectives of this. Okay, so let us go through the objective part of this. Now, length of the perpendicular. This one I'll be reflection of a line in another line. I did not discuss, in fact. I did not discuss. I discussed image and reflection. I did not discuss this. I'll be discussing this in the concurrent lines concept. That is family of lines concept whenever we get. In that one, I will discuss that. This one. This part I'm saying. This one. Just go through the statement once. And remember, remind me that. What is that? A line is there. Image of a line. This is one line. Okay. And this is another line. Now, the image of this line, the image of this color line in the black line. In the black line is to be found out. That means this is the image. This is the image. So, if you see the data properly, image of the line ax plus by plus c equal to 0. This is the line whose image is taken. This is nothing but ax plus by plus c equals 0. Okay, and the mirror line, I must say, mirror line. This line is ax plus by plus c equal to 0, and the mirror line is lx plus my plus n equal to 0, and the line whose the reflect, or you can say the image line. This is the image line. This image line formula is this: L square plus m square into ax plus by plus c is equal to twice of al plus bm into lx plus my plus n equal to 0. That I will derive, that I have to derive anyway. I will show you the derivation of it compulsory, because the concept, what we do now when we are deriving a particular theorem or whatever, the concept, what we do, what we apply, how we apply our brain to solve it, that will be very much useful in solving the problems. That is why simply learning the formula, sometimes if it is inevitable we have to do that, but whenever the derivation part is possible, better you learn the derivation also. So this part I will be discussing in the set of concurrent lines, because these are the three lines here. You can understand this set of concurrent lines. We'll be doing that. We'll be doing that in the part of concurrent lines or family of lines. Now the angular perpendicular distance, just now I derived it. This is distance of a point from a line, the length p of a perpendicular from the line is x1 y1 is a modulus of x1 plus b1 plus c by root or a square plus b square, and from the origin is mod c by root or a square plus b square, and the normal form, just now I used it, x cos alpha plus y sin alpha is equal to p. Distance with the parallel lines modulus of c1 minus c2 by root over a square plus b square. We are not worried about the derivations there. So next is the equations of the bisectors of the angles between two straight lines. We'll be doing that, but before that, we will work out some problems. We'll work out some problems on this. Okay. Now, yesterday, I think we stopped at a particular problem. Arun, do you tell me where did we stop? If the lines are equally inclined to the line y is equal to mx plus 4, then m is equal to, I think I derived it. Okay, anyway. Now we will have the next part of it, perpendicular distance, length of the perpendicular, this is a straight question. I need to discuss this. The distance of the point minus 2, 3 from the line x minus y is equal to 5. Straight away apply the formula. It is modulus of. He wrote even the formula also, modulus of x1 minus x1 ax1 plus by1 plus c by root over a square plus b square. It's nothing but 10 by root 2. It's nothing but 5 root 2. Straight question, please. Straight question. Minus 2, minus 3, minus 2, minus 3, minus 5, minus 10 divided by root 2. So what is this? The answer is given to be. Okay, next question. Okay, 5 root 2 is the answer. Distance between the lines. This is what I discussed. Just observe these two lines, please. First line is 4x plus 3y is equal to 11. Second line is 8x plus 6y is equal to 15. The coefficients are not equal, please. The coefficients are not equal. Here, the coefficients, you have to make them equal, multiply with 2. This is 8x plus 6y. Minus 22 equal to 0. This is 8x plus 6y. Minus 15 equal to 0. Distance between the parallel lines, C1 minus C2. This is minus 22 plus 15. 7, I am writing directly. Minus 22 plus 15, 7 by root over 8 square plus 6 square is 100. 100 and the root is 10. So 7 by 10. So C is the answer. Straight questions, please. Let us not waste time on this one. Direct questions. Okay. Next. Next, please. If the length of the perpendicular drawn from the origin to the line whose intercepts on the axis are A and B be P, then you see, it's also a simple question. You can understand that. The length of the perpendicular drawn from the origin to the line whose intercepts on the axis are A and B be P. Then what are the intercepts given? A and B. What are the intercepts given? A and B. So what is the line equation then? It is x by A plus y by B is equal to 1. Perpendicular distance from the origin is given to be P there. So P is equal to modulus of, from the origin now, mod C by root over A square plus B square. 1 by A square plus 1 by B square. Square and cross multiply, please. 1 by P square is equal to 1 by A square plus 1 by B square. That's it. That is a condition. Let us check it out. This is D option. Option D. Option D, please. Okay. Let's clear it off. Next question. The point on the x-axis whose perpendicular distance from x by A plus y by B is equal to 1 is A. Is. So what is the question there? He needs the perpendicular distance. No, it is given that the perpendicular distance from a particular point on x-axis to this line is given to be A. There is, I think the question is direct, but maybe some simplification part you must take care of. So let me do that. So here you are given a Point on, you have to find out a point on x-axis. This is y-axis. And there is a point on x-axis. There is a point on x-axis which is P. We don't know. We don't know. Let it be some whatever, k comma 0 or x comma 0, whatever. K comma 0. Now a line is given, which is given in the intercept form. This is a line given, which is nothing but x by a plus y by b is equal to 1. Now the perpendicular distance from this point to this line is given to be P there. Just to avoid confusion, let me remove that P there. I'll make it some A. This distance is given to be small p there. This is the data given. Now, find out the perpendicular distance from K0 to this line. It is modulus of AX1, that is K by A plus B by 1, 0 minus 1 divided by root over A square, that is 1 by A square plus 1 by B square. Is given to be what? P, please. It is given, already declared that the distance is P. Okay. Now, you have to get the value of K there because we need the point there. Finally, you have to get the value of K. This K is to be find out. Okay. We have to find out the value of K here. This one is to be find out. So you have to simplify accordingly. So what is that you get? K by A minus 1 is equal to, I think the distance is given to be A, I think. Let me check the question box. Yeah, it is given to be A. A please, not P. This is not P but A. This is A. Now K by A minus 1 is equal to plus or minus A into root over A square plus B square by A square B square. I have taken LCM, which is nothing but K by A is equal to 1 plus or minus A getting cancelled, B comes out, 1 by B root over A square plus B square. I said no, only simplification part is difficult. It's not a big problem, but simplification you have to do carefully. And generally you will be forgetting writing that plus or minus also sometimes. So what is K here? A plus or minus A by B root over A square plus B square is the final answer. So comma 0. The point is A plus or minus A by B root over A square plus B square. Comma 0 is the answer. Let us check it out. Let us check it out. The options here. B by A. I have taken LCM also here. A by B. A by B into what is the answer we have got? A taken common here. A taken common here, A by B into B plus or minus this, you take A common here. Then what happens? You will get let me show you that. One by take A by B common directly because he has given the option with A by B. So take A by B common. You will get then it is B plus or minus root over A square plus B square. That's it. That is the answer. I have taken A by B common. Let us check. I'm removing this, eliminating this, erasing this. Just a moment. Now check the answer. A by B into B plus or minus root over A square plus B square, comma 0. This is the answer, please. That is the answer. Only simplification part there, nothing other than that. Nothing more is to be discussed except the simplification part. So yeah, next one is the vertex of an equilateral triangle is 2 minus 1 and the equation of the base is x plus 2y is equal to 1. The length of its side is. Let me write the data first. Let me write the data. Let me write the data first, and after that we will work out. What is one vertex of the equilateral triangle? Equilateral triangle, one of the vertices is given to be 2 minus 1. And let me say this as some A. A is given to be 2 minus 1. And what is the base given? X plus 2y is equal to 1. This is also perpendicular distance based problem. We need the length of the side now. We need the length of the side. This is the perpendicular distance. In an equilateral triangle, as you know, all the centers will coincide. Centroid, circumcenter, incenter, orthocenter, all the centers will coincide. This is a perpendicular now. Okay, now I need the distance here. I need the distance here. Let me say this length of the side be A. Let it be A. And let it be P, perpendicular distance. And as you know, in an equilateral triangle, the angle is 60 degrees. Okay, now this P, perpendicular distance, is nothing but modulus of AX1. 2 modulus of 2 minus 1 divided by root over 1 plus 4. It is 1 by root 5, please. Now apply, opposite side. We need hypotenuse here. Find out sine 60. What is sine 60 degrees here? P divided by A. What is A now? What is A? P we know. Cross multiply. P is 1 by root 5. Sine 60 root 3 by 2. Shifted this side. 2 by root 3. It is 2 by root 15, please. 2 by root 15 is the answer. So length of the side of the equilateral triangle should be 2 by root 15. Let us check the options. B is the answer. B is the answer, please. Simple question only. Here also, the perpendicular distance concept is used. Let's move on to the next question. This is concurrent lines. I have to discuss this. We've not done the problems based on the image or reflection. 4 minus 13, 5x plus 6y. I think we did it. I discussed this in the previous session. Okay. Now these are some important properties that are to be understood. With regards to area of the triangle, ax plus by plus c equals to the coordinate axis, area of the rhombus, area of the parallelogram, and this is foot of the perpendicular. We don't need this because we already derived it. Now I'll be discussing this finally. At the end I'll discuss that. Now the coordinates of the foot of the perpendicular drawn from 2, 4 to the line. Here, if only one answer is there, you can straight away go for verification, please, what I'm saying. If only one answer is there, you can straight away go for verification. What is the meaning of foot of the perpendicular? If a line is drawn from a point, if a line is drawn from a perpendicular line is drawn from a point to another line, this is a perpendicular line, and this is the line given, then this is called the foot. This is called the foot. Where does this foot is lying? Lying on the line itself. Where does the foot is lying? Lying on the line itself. So just verify the options by substituting in the line equation. Then it is done. Like that also, you can plan, you can go, but if the more than one correct answer is there, then you have to go for the method. Let us substitute 1 by 3, 3 by 2. 1 by 3, 3 by 2. Right here, please. 1 by 3 plus 3 by 2. What is it? 9 is not is equal to 1. Similarly, this one minus 1 by 2 plus 3 by 2. 2 by 2, 1. It is satisfying. But don't stop there. Verify this also. 4 by 3 plus 1 by 2. No, it will not also satisfy. 8 plus 3. 9. It will not also satisfy. 3 by 4 minus 1 by 2. 6 minus 4 is 3 by 4 minus 1 by 2. 4 LCM, 3 minus 2. 1 by 4. No, it is not also satisfying. Only one option is satisfying. So you can say the answer directly as B. As B, without working out the problem. So this is one of the verification methods you have to understand. Otherwise, you apply the formula what I gave you, or otherwise you apply the method what I taught you. Okay. Now, going to the next one. Example 3.2 here. The area enclosed within the curve mod x plus mod y is equal to 1. Let me draw that for more understanding, or for better understanding how to consider, how to split such equations into 2 or more than 2. I'm teaching you the concept of modulus now. Just follow it carefully. The curve given is mod x plus mod y is equal to 1. The curve given is mod x plus mod y is equal to 1. Let me write that. What is the curve given? Mod x plus mod y is equal to 1. Now, understand it carefully. Here, x greater than 0, y greater than 0, both are positive. No need to think anything about the modulus. Remove the modulus directly. X plus y is equal to 1. This is the first line, remember. Now, x greater than 0, y less than 0 implies x greater than 0, x, y less than 0, minus y. Remember this, whenever it goes to be negative, whenever it is negative, you have to put a minus while removing the modulus to make it plus. What does it mean by putting minus here? When y is already negative, if you put a minus before it, that becomes minus or minus plus. That is the purpose of modulus. Why do we use modulus? We use modulus just to make the quantity positive. That's what it is. Similarly, x less than 0, y greater than 0. You can say that now implies x less than 0 means mod x becomes minus x. Y greater than 0 means mod y becomes y is equal to 1. Third equation. Similarly, x less than 0, y less than 0 implies both are negative. Minus x minus y is equal to 1. This is what you have to understand. So, Arun, respond. Do you understand this? Arun, respond whether you understand this or not. So, simply by looking at this equation mod x plus mod y is equal to 1, don't think that it is only single equation. No, it is 4 equations containing. It contains 4 equations. That is what you have to understand, please. That is what you have to understand. Okay, now you have to find out the area enclosed by these 4 lines. Question is simple after you learning this. You will say the answer directly after me teaching this. Okay, now let us draw x-axis and y-axis for the better understanding. This is x-axis and this is y-axis. This line is x plus y is equal to 1. That line is x plus y is equal to 1, please. That means it makes an intercept of 1 unit. I'll take the normal line, not the pointed line. This is the first line, please. It will not extend. It will be exactly here only because x is greater than 0. Let me draw. This x greater than 0, y greater than 0 lies in the first quadrant. It will not go up, it will not go down. Exactly, it will be like this. Coming to the next one, y intercept negative and x intercepts positive. That means it will be exactly perpendicular to this, like this. How can we say that the angle between them is 90 degrees? Check the product of the slopes. Its slope is minus 1, its slope is plus 1. Its slope is minus 1, its slope is plus 1. Product of them is minus 1. Okay, similarly the next one, minus x plus y is equal to 1. X negative, y positive. X negative, y positive. It goes like this. This is like this. Next one, you can say lies here. So basically what is that you have to understand? The angle between the adjacent lines is perpendicular to each other and hence it forms a square. and hence it forms a square. What are the points here? This is 1 comma 0 because the line is x plus y is equal to 1. This is nothing but 1 comma 0 and this is nothing but 0 comma 1. The distance between them is nothing but root 2, please. Therefore, area x square, side square, root 2 whole square is nothing but 2. That's it, please. This is the area of the square formed by the lines mod x plus mod y is equal to 1. The equation is shown to be only 1, but it gives you 4 lines. Don't forget that. It gives you 4 lines. The answer is root 2 whole square. Answer is root 2 whole square. So it is 2 square units there. 2 square units. So 2 is the answer. D is the answer here. Okay. Now, let us move on to the next question. x1, x2, x3, y1, y2, y3 both are in GP with a common ratio. Then the point x1, y1, x2, y2 and x3, y3 lie on a straight line, lie on an ellipse, lie on a circle or the vertices of a triangle. Now, this can be easily understood. x1, x2, x3, y1, y2, y3 are in GP, he is saying. So, let us take through verification, the method what he has taken is, in GP, everyone knows A by R, comma A, comma AR in GP. You can apply that, or otherwise, go comfortably like this. Let me take x1 as 1. Let me take x1 as 1, x2 as 2, x3 as 4. 1, 2, 4 are in GP now. With a common ratio, same common ratio is saying, what is the common ratio? I have taken 2. So let me start this with 2. Common ratio 2. 2 into 2, 4. Common ratio 2. 4 into 2, 8. So what is that? I have taken x1, 1, x2, 2, x3, 4. y1, 2, y2, 4, y3, 8. Now what are the points here? What are the points? 1, 2, 2, 4, 4, 8. All the points. I'm following the verification method, please. I'm following the verification method. Cross verification, I'm giving some numerical values such that it satisfies the given condition that are in GP. Now, here, let this be A, this be B, this be C. Slope of AB is equal to 4 minus 2 by 1. What is slope of BC? 8 minus 4, 4 by 2. 2 slopes are equal and hence they are collinear. That is the answer. These points are collinear. Let us check it out. Lie on a straight line. Collinear means they lie on a straight line. Going to the next question. That's the previous question, you can understand. Good question, please. Arun, respond through voice, please. Arun, respond through voice. I am sending you the link. I am sending you the link. Respond through voice. have sent you the link. Just respond, please. Whether link is needed or you can directly come, let me check once. I don't think link is needed. Yeah. Yes, Arun? Yes, can you talk once? Which one are you talking about? How do we verify if it lies on a circle? Yes, that's a good question. We will find out the equation of the circle and we will substitute. Well, you will have 4 points for a circle. You will have 4 points for a circle. Now what we do, we will find out the equation of the circle using 3 points and we will substitute the 4th point in that circle equation. Then if it satisfies, they are said to be concyclic.
Yes, sir.
They lie on a circle. They lie on a circle. That's good, Arun. Now, Arun, whenever you get
Sir.
down now, you come on to the voice and you ask me, and immediately you, what I'm doing, just moment, be online. I'm muting myself. I mute myself. Now, do you listen to me? Arun? Arun, do you listen to me? Arun, are you there? Arun? Hello?
Hello?
Arun?
Yes, sir.
What I'm doing, I'm muting myself. Then also, are you listening or not? You tell me, because I will be, my voice will come through YouTube. Let us check it out once. I'm muting myself in this one. You tell me whether you listen to me or not. Are you listening to me? Yes, Arun? Are you listening to me?
Yes, sir.
After muting also, are you listening to me?
Sir, I am listening.
Now do you listen to me? Okay. Let's move on to this question, which is the problem related to a square. Which is problem?
Yes, sir, I am listening.
Okay. Then mute yourself, please. Mute yourself.
Okay, sir.
This is a square of side A lies above x-axis and has one vertex at the horizon. The side passing to the horizon makes an angle with the positive direction of x-axis, the equation of its diagonal not passing to the horizon. See here. I'll take up this diagram to explain. Otherwise, we'll draw the diagram. No issues. Now, it is like this. This is x-axis. Now, a square is defined to be, like this. it is making an angle alpha. It is making an angle alpha. One side of it is passing through origin and making an angle alpha with positive x-axis. And hence, that alpha is also, limitations are there. Alpha has also limitations. It lies between 0 and pi by 4. This is another square. That is, this is another side. This is the completed square now. When this is a completed square, what is the data given there? According to the data, this angle is given to be alpha. And this side is given to be A. And this is 90, as you know. This is also 90 because it's a square. This is also 90 because it's a square. Now, let me write the coordinates of A. Horizontal component, A cos alpha, A sin alpha. Okay, now just observe. What is this angle here? It is also 90. Then what will be this angle? This angle, it is alpha, it is 90 plus alpha, totally 180 minus 90 plus alpha. This angle becomes 90 minus alpha. Just check it out. That angle becomes 90 minus alpha, please. Then let us write the components for this. Is, I think he set it as ABCD. Let me name it like that only. Let me name them as ABCD. A, B, C, D. Then if you write the components for this is also of length A because it's a square, all the sides are equal. Now, because it is lying in negative x-axis side, this is A cos of, I am writing it here. Finally, we will write 90 minus alpha. A sin of 90 minus alpha. What is A cos of 90 minus alpha? A sin alpha. What is A sin of 90 minus alpha? A cos alpha. But don't forget, it is lying on negative x-axis side, and hence you have to take this minus. And hence you have to take this minus. Now what is that we need? We need the equation of the diagonal BD. That's what the question is. We need the equation of the diagonal BD, please. This one is needed. You know 2 points? You know 2 points B and D. You can straight away apply the 2-point form and you can write the equation of the line. So, and the short form what I taught you to write this through the slope will be useful here. So, BD line equation. BD line equation. Write the slope so that it will be easy for you. Slope is y2 minus y1 by x2 minus x1. I am writing it directly, A sin alpha minus A cos alpha, that is sin alpha minus cos alpha divided by cos alpha plus sin alpha. Therefore, line, multiply numerator with x, multiply numerator with x, denominator with y, that is sin alpha minus cos alpha into x. Because you have plus here, put minus here. Cos alpha plus sin alpha into y. Cos alpha plus sin alpha into y is equal to, substitute the point please. What is the point? Either this or that. Is equal to, I am writing it here, cos alpha minus sin alpha into, substitute this point, a cos alpha minus of cos alpha plus sin alpha into a sin alpha. This is a short form of writing the line equation I taught you in the beginning itself. In the first video, I explained this. This is a cos alpha minus a cos alpha sin alpha. This is also minus a cos alpha sin alpha. These two getting cancelled. So, what is the simplified form of it? A into cos square alpha plus sin square alpha. This is minus a. A into cos square alpha minus sin square alpha. So, it should be a cos 2 alpha. So the line equation must be this: sin alpha minus cos alpha into x minus of cos alpha plus sin alpha into y is equal to a cos 2 alpha. Should be your answer. Let us check it out. But somewhere the sign has gone wrong because no cos 2 alpha present in the constant. Let us check it out once. What is that? Cos alpha sin alpha minus cos alpha. This one we wrote wrong. That one we wrote wrong there. This is sin alpha minus cos alpha, no? This is plus sin alpha. And this is minus cos alpha. So sin alpha minus cos alpha means, what is that? You are getting cancelled. This is common. A sin alpha cos alpha minus a sin alpha cos alpha getting cancelled. And it is minus a cos square alpha minus of a sin alpha. So what is that remaining? If you take minus a common, you will get 1 in the brackets. You will get 1 in the brackets. Why 1? Cos square alpha plus sin square alpha is 1. This is what the equation we have got. Multiply throughout with minus. Then what happens? This becomes cos alpha plus sin alpha into y. And it is minus x into sin alpha minus cos alpha is equal to a. This will be given in the modified form. Let us check it out. This is y into cos alpha minus sin alpha. No. It is y into cos alpha plus sin alpha, it is there. Minus x into sin alpha minus cos alpha, it is there. That is equal to minus a becomes plus a. So your answer must be B. Your answer must be B. Okay, that's what it is. Let us see now the angular bisectors. Let us see now the angular bisectors, which is also an important concept as far as the objectives are concerned. As far as objectives are concerned, the angular bisectors is also important, and the theoretical part the formula why I am deriving the concept of the derivation, the property what we use in the derivation is important here. The property which we use in the derivation is important here. Okay, so this is the angular bisector's derivation. Because further you will have to remember some conditions to decide whether the given angular bisector is or got angular bisector is acute angle bisector or obtuse angle bisector. So now angular bisectors, please. There are two lines here. This line, let me write a1x plus b1y plus c1 equal to 0. This line, let me take a2x plus b2y plus c2 equal to 0. Now we need the angular bisector of this. Okay, we need the angular bisector of this. How many such angular bisectors will be there? 2 will be there. Angular bisectors will be 2, but one is acute angle bisector, other one is obtuse angle bisector. Now what is the property? If you take any point on the angular bisector, P x naught y naught, let me say, P x naught y naught is the angular bisector. A point on the angular bisector. Its distance from the first line is equal to its distance from the second line. Always, please. The property. This is what the property I want to explain you, or I want to remind you the property. What is the property? Take any point on the angular bisector. That point is, if it is a point on the angular bisector, it is always at equal distance from the lines. That is, it is PA, this is PB. So your PA is equal to PB. Apply the perpendicular distance formula. Why we are taking up after the perpendicular distance? Because we derived already the perpendicular distance. That is why we are taking up this after the derivation of perpendicular distance. So if it is x naught y naught, perpendicular distance, please, modulus of this one, a1 x naught plus b1 y naught plus c1 divided by root over a1 square plus b1 square is equal to modulus of this one, perpendicular distance, a2 x naught plus b2 y naught plus c2 divided by root over a2 square plus b2 square. This is what we have got. Now this is to be converted as the locus, because we have written it for a particular point x naught y naught, but this should be generally expressed. So this x naught y naught is every point at any, you have to make that x naught y naught to make every point at any point on the angular bisector, which is nothing but the general form. Implies convert that x naught y naught as xy. So a1x plus b1y plus c1 divided by root over a1 square plus b1 square is equal to plus or minus a2x plus b2y plus c2 divided by root over a2 square plus b2 square. So, which implies that a1x plus b1y plus c1 divided by root over a1 square plus b1 square is equal to plus a2x plus b2y plus c2 divided by root over a2 square plus b2 square, and a1x plus b1y plus c1 divided by root over a1 square plus b1 square is equal to minus of a2x plus b2y plus c2 divided by root over a2 square plus b2 square. How many angular bisectors we have got here? We have got 2 angular bisectors. One is with plus, other one is with minus. One is with plus, other one is with minus. You got two angular bisectors. But this angular bisector is acute angle bisector or not? This angular bisector is obtuse angle bisector or not? We don't know that. We don't know that. For that one, you have the condition. For that one, you have the conditions. Condition, please. Condition number one. Very important for the objectives. Generally, in the board level, these are not taken. It is mainly for the objective questions. Always number one. Keep the constants always positive. What does it mean? I'll explain that. Number two, find out A1, A2 plus B1, B2 then. Keep always the constant positive. Find out the sign of A1, A2 plus B1, B2. If A1, A2 plus B1, B2 is plus, by taking minus here, you'll get acute angle bisector. By taking plus here, you'll get obtuse angle bisector. If it is minus, this is reversed, plus and minus. So always, whatever the sign is there for A1, A2 plus B1, B2, whatever the sign is there for A1, A2 plus B1, B2, that will be the same sign for obtuse angle. Obviously, the other one is for acute angle. Whatever the sign is there for A1, A2 plus B1, B2, that will be the sign for the obtuse angle. And the other one will be exactly opposite, positive, acute angle bisector. But before this, very important point. Before this, very important point is that keep the constants always positive. Keep the constants always positive. Okay. Now similarly, containing the origin. Containing the origin. What does it mean by containing the origin? The meaning of it also you must know. For example, this is an acute angle bisector. Origin is here. Origin is here. We say that acute angle bisector is containing the origin. We say that the acute angle bisector is containing the origin. Unlike this, the origin is here. Origin is here. We say that the obtuse angle bisector is containing the origin. That's what it is. For that also, number one is common. For that also, number one is common. So, if you take this plus, then obviously acute angle will contain the origin. Acute or otherwise simply write like this. If we get this plus here, then obtuse angle, whatever the sign is there, you will get the same. Plus obtuse contains the origin. If we get minus here, then you will get here also, you will get obtuse contains the origin. That means whatever the sign you get, you will get the same for the angular bisector which contains the origin. Okay, this is what you have to understand. See, if I explain it like this, so that quantum spark, sir, how can we find area bounded by a parabola and circle with integration? Now, it is not related to this session. You ask me that separately through WhatsApp or in your that polymath WhatsApp group. You post that question. But this session is not related to that. I'm taking up only the questions that are related to this straight line concepts only. Straight line concepts only. So this is what you have to understand. Let me close it by taking a suitable question so that you will better understand it, because I explained it already the concept here. So let me go through the question now. Okay, let us see that. Let us see this in the printed format so that you will also be remembering very well. The equation of the bisector of the angle between the lines is, this is what I derived. This is what I derived, please. This one. A1x plus B1y plus C1. A1x plus B1y plus C1 divided by root or A1 square plus B1 square is equal to 8 plus or minus 8x plus B2y plus C2 divided by root or A2 square plus B2 square. So algorithm, this is what I explained now. Algorithm to find the bisector of the angle containing the origin. The equations are this. To find the bisector of the angle containing the origin, we proceed as follows. See whether the constant term C1 and C2 in the equations of the two lines are positive or not. If not, then multiply both sides with the equation with -1 to make the constant term positive. Positive. That means you have to keep the constant terms positive. That's what I explained. Now obtain the bisector corresponding to the positive side. Corresponding to the positive side. This is the required bisector of the angle containing the origin. Okay. So he has given it simple, very simple, very simple. After making the constants positive, the plus sign contains means he has not mentioned about A1, A2 here. Let me check. Let me check, please. One moment. One moment, please. Let us take the question and then we will move on to this. Let me take a question, please. Here it is. Here it is. These are the angular bisectors, and this is, see whether the constant term C1, C2 in the equations of the two lanes are positive or not. Obtain the bisector corresponding to the positive sign. This is for the angle containing the origin. To find the acute and obtuse angle bisectors. This I explained first. What is that? Make the constant term positive if not. Determine the expression A1, A2 plus B1, B2. If A1, A2 plus B1, B2 greater than 0, the bisector containing plus sign gives the obtuse angle and minus gives the acute angle. If it is less than 0, plus sign gives you acute and minus sign gives you obtuse. This is what I gave as a table. Always the bisectors are perpendicular to each other. Very important point, please. Always the bisectors are perpendicular to each other. Okay. Now, let us take a question. See this one. The equation of the bisectors of the angles between the lines mod x plus mod y. Mod x is equal to mod y. Mod x is equal to mod y. This is not a big question and you need not have to apply any formula here. This is all common sense. This is all common sense. These are the angular bisectors of the coordinate axis. One line is remove the modulus x is equal to y. Remove the modulus x equal to plus or minus y. One line is x is equal to y, other line is x equal to minus y. Okay, so the angular bisectors of these two are nothing but x-axis and y-axis. That's all. What is the equation of x-axis? Y equal to 0. What is the equation of y-axis? X equal to 0. So that is the answer. That is the answer. Let us go to the next question. The equation of the bisector of the acute angle between the lines. This is what you have to see. Very important, please. Very important. Follow this carefully, because the first condition makes you confused. What I mean to say by first condition? Here it is plus 7. Here it is minus 2. You should not apply the formula directly unless you make both of them positive. Unless you make both of them positive, but he did it in a different way. But I'll explain you like this. Simple only. What is that? 3x minus 4y plus 7 equal to 0. 3x minus 4y plus 7 equal to 0. Second one is not containing the constant term positive, and hence multiply throughout with minus here. What happens? Minus 12x plus 5y minus 12x plus minus 5y plus 2 equal to 0. This is minus 5y because we want to make it positive. Now both are positive, you can apply. What is it we need? Bisect of the acute angle we need. So find out a1, a2 plus b1, b2. What is a1, a2? Minus 36 plus 20. Minus 36 plus 20. Minus 16 less than 0. And hence acute angle bisector is got by. Because it is negative, you'll have to take opposite sign then. So 3x minus 4y plus 7 divided by 5 minus you have got here. A1, A2 plus B1 negative you have got here. So you have to take plus for this. Plus on the same line. Minus 12x minus 5y plus 2 divided by 12 square plus 5 square under root 13. This is to be simplified. And hence finally you will get this. If you simplify this, you will get this as the answer. Cross multiply, just check it out once. This is 13 into 3, 39. This is minus 60. Minus 60 brought this side becomes 39 plus 60, 99. 99 divided with 9, you will get 11x. Here also, it is minus 25. It is minus 52. Minus 52 plus 25 becomes minus 52 plus 25 becomes minus 27. Divided with 9, 3y you will get. Minus 3y you will get. So that is the answer. This is a method to remember as far as the angular bisectors are concerned. Okay. And the next concept what we are going to discuss is a set of concurrent lines. We'll be discussing in the next session. See you till then. We'll meet again in the next session. Have a good day.